Hello all, welcome back to today's lecture. This is technically a supplement of the lectures in metabolism, just to let you know how we calculate the ATP yield and then trace the parts of substrate and product in various metabolic pathway. Remember, we said glycerol is usually a product that comes from the mobilization of fatty acid, and the glycerol enters the bloodstream and gets into the glycolysis, where the fatty acids themselves get into lipid metabolism, particularly beta oxidation. So what happens to that glycerol? What is the fate? How does it go, and what amount of ATP is released from it? That's basically what we're going to be talking about in this lecture. Now, so the basic thing we're going to do is to determine the ATP yield from glycerol breakdown, complete glycerol breakdown. So the question will usually go this way. If you see it in exam, it will say determine the amount of ATP generated when from the complete breakdown of 1 mole of glycerol. We're talking about usually 1 mole of glycerol. Remember, in the pathway of glycerol, we've already established that the moment triglyceride, remember triglyceride will be broken down, TG or triglycerides, are usually broken down to their respective fatty acid, and then glycerol leaves. And remember, we said the glycerol enters glycolysis. How does it do that? That is the subject matter of this lecture. We want to know what happens in glycolysis actually, not just enters glycolysis. What is actually happening in that glycolysis particularly? That will be our subject matter in this class. So this is, I'll call this glycolysis. This is my G. It's not coming out the way I want it, but it's fine. This is, okay, perhaps I should say glycolysis, please. I'm going to leave it at this point. Okay, so let's see what's happening. Remember, the moment glycerol enters the bloodstream, it gets into the cytoplasm. This reaction is taking place in the cytoplasm. This particular reaction is taking place in the cytoplasm. What happens? Glycerol is converted to glycerol phosphate, and the enzyme that does this is a glycerol kinase. We don't need it in this case, but just know that ATP donates one of each phosphate group to glycerol at this point, and then to become glycerol phosphate. Glycerol phosphate undergoes a dehydrogenation reaction to be converted to dihydroacetone phosphate. It is this dihydroacetone phosphate that enters glycolysis. How does it enter glycolysis? Let's see at what point it joins glycolysis. Now, before we do that, let's remember that 1 mole of every cytoplasmic NADH, you said it earlier, because of the shuttle mechanism involved, generate 1.5 moles of ATP. But the ones that are generated in citric acid cycle that happens in the mitochondria gives us 2.5 ATP. And FADH in the mitochondria gives us 1.5 ATP. These are important reminders. Now, the pathway that you need to be familiar with are this pathway. So dihydroacetone phosphate joins from, this is dihydroacetone phosphate. This is where it joins from. And from here, the dihydroacetone phosphate continues through the path of what glycolysis. The moment it finishes glycolysis, what happens again? Pyruvate gets into the mitochondria, and from here again, it continues and it is broken down completely in the citric acid cycle. And the reducing equivalents that are generated will now do what? Will enter the electron transport chain and be used to generate ATP. So let's start this job. So now, like I did before, you're going to be given a table like this. I'm going to show you this table. We're going to start from the first. So let's begin to take stock. Remember, in doing this, we do not have to worry about the names of the enzymes or the names of parts that does not involve the reducing equivalent. Our interest is those parts involving reducing equivalents. Let's take it off from there. So the first thing we're going to have is that glycerol is converted to glycerol phosphate. That's the first thing that happens. Let's go to our table and populate it. So the first step is glycerol will be converted to glycerol phosphate. And what is happening here is that 1 mole of ATP was used. So a mole of ATP was used, as we saw. You can go back and just look at it, just for a reminder. A mole of ATP was used. That means you are losing ATP. So if you're losing ATP, what happens? If you use ATP, that means it's a minus 1 ATP. In the second step, let's see what's happening there. In the second step is the hydrogenation reaction, whereby glycerol phosphate is converted to dihydroacetone phosphate. Here, 1 NADH was generated. It was generated. So we go back here. So it's going to be from glycerol phosphate to dihydroacetone. Oh, okay, let me just put this as phosphate. Let me make it short. Here, 1 NADH. Remember, we're talking about only glycerol. It's just 3 carbons. So we're not talking anything about 2. So nothing is happening 2. Everything is happening once. So 1 NADH was generated. And 1 NADH is generated in, remember, in cytoplasm. Because this reaction is taking place in the cytoplasm. That is taking place in the cytoplasm will give us 1.5 mole of ATP. We go back to that and populate it. So this will give us, of course, the plus 1.5 ATP that is generated. Yeah, so we've established that fact. Now, remember, after that point, what happens? It enters glycolysis. Now, you're not expected to write glycolysis. Of course, in the exam, we'll always tell you to have the metabolic map with you. So what we're going to do next is to enter glycolysis. In glycolysis, it enters as dihydroacetone phosphate. So dihydroacetone phosphate will now be converted to what? All the dihydroacetone phosphate will be converted to glycerol phosphate. No ATP involved, no reducing equivalent. Look at where something is happening. Now, glycerol 3 phosphate will now be converted to 1,3-bisphosphoglycerol. Remember, this is my diagram, my picture for what? For breaking down of glucose, which happens in 2s. This does not happen in 2, so it does not happen in 2. Don't forget, everything here regarding glycerol is happening in 1, because glycerol is just 3 carbons. I know this guy is 3 carbons, this guy is 3 carbons, so you can have it too. Now, so it's going to go from glycerol 3 phosphate here to 1,3-bisphosphoglycerate. And if you look at it, 1 NADH was produced. We go back and populate that table. Wait. So it's going to be from glyceraldehyde phosphate to 1,3-bisphospho. I'm going to use shortcut glycerate. Here, 1 NADH was generated. And if 1 NADH was generated, it's going to be, remember this is also happening where? In the what? In the cytoplasm. Glycolysis happens in cytoplasm. It will generate plus 1.5 ATP. So what happens next? You're going to now continue the path. All this part will now continue in glycolysis. What does that mean? You're going to now go to the next one. From 1,3-bisphosglycerate to this, you generate 1 mole of ATP. You're going to go from this, nothing happens here, nothing happens here. The next one will be from phosphonol pyruvate to pyruvate, 1 ATP. You keep going down until you get to this point. You get to the mitochondria. Remember, everything happening after this point is mitochondria. I think I moved my cursor a little bit. That should be home. So like I said, everything happening after glycolysis, all of them, everything happening after that is in what? Is a mitochondria. So in mitochondria, every NADH now worth about 2.5 and FADH worth about 1.5. So after this point, we'll now continue with the mitochondria at this part. Remember, this is the mitochondrion. We're going to continue from this part. And then until we break it down and continue the cycle again. This is the complete breakdown of glycolysis. So what I'm going to do next is that I'll not keep filling up the page, because everything that happens from here, we've done it in the breakdown of what? Glucose. So I'm going to show you what it's going to be to populate the table, and then what we're going to do is now tabulate and calculate how much ATP is needed. So if I go to my next page, I'm going to show you this. Remember, we did this already. From glycerol to glycerol phosphate uses 1 ATP. From glycerol to this gives produce 1 NADH, which is equivalent 1.5 ATP. From glycerol 3 phosphate to 1,3-bisphosphate, we got 1.5. From 1,3-bisphosphoglycerate to 3-phosphoglycerate, generated 1 ATP, which is 1 ATP at this point. From phosphoenol pyruvate to pyruvate, we got 1 ATP, which is it. Remember, everything happening here is what? Is cytoplasm, cytoplasm. Whereas the rest of everything happening here is happening in what? In mitochondria. Let me try to write it. This is happening in mitochondria, in mito. So now, in mitochondria, what happens? Pyruvate leaves the cytoplasm, enters inside the mitochondria where the reaction continues. From pyruvate to acetyl-CoA, generate only 1 NADH. Therefore, 1 NADH is 2.5 in mitochondria. Isocitrate to alpha-ketoglutarate, 2.5 ADP. Then, alpha-ketoglutarate to succinyl-CoA, another 1 NADH, which is 2.5 ATP. From succinyl-CoA to succinate is 1 GTP, which is equivalent to 1 ATP. From succinate to fumarate, we got 1 FADH2, which is equivalent to 1.5 ATP. And from malate to oxaloacetate, we got 1 NADH released, which is equivalent to 2.5. So if you add everything here together, you're going to get 17.5. 17.5 minus 1 ATP gives us 16.5 ATP. So the complete breakdown of 1 mole of glycerol from the cytoplasm to complete breakdown in the mitochondria will yield a net ATP of 16.5. Just because this is happening, remember again, we're assuming that everything is happening in the skeletal cell, in the muscle cell, that uses what we call the glycerol phosphorus shuttle. That is a much more simpler shuttle that generates less ATP than the other shuttles. But we're not going to go into those mechanisms. Just anytime I ask you this question, I'm assuming you are telling me what is happening in the skeletal muscle. So in the skeletal muscle, the complete breakdown of 1 mole of ATP will generate the complete breakdown of 1 mole of glycerol will generate 6.5 mole of ATP. And now we go to the next part of this, which is tracing the parts of products and substrates. So here we'll be talking about the parts of substrate and product. What do I mean by that? We want to know if glycolysis goes to, let's say, acetyl-CoA, what part did it take? Usually we tell students to do this with their metabolic pathway, but to be able to trace the parts correctly. However, you need to understand the flow in a metabolic pathway. So usually you see the question like this. It says, trace the path of substrate to product using arrows from fructose to acetyl-CoA. Now, at this point, I only need the names of the molecules that are involved. I don't need the names of the enzymes or the energy equivalent. So I don't need the NADH or the FADH2 or the ATP. No, I just need the names of an arrow showing me that you understand that pattern. So since I talked about fructose, you need to have a metabolic pathway involving fructose. And I have that in this page. Remember these storage mechanisms about monosaccharide and the glycogen that I showed you? If you remember this, now this is galactose, this is glucose. So we're talking about fructose. So fructose starts at this point. So watch me, I'm going to trace this thing until we finish. I get to what? Acetyl-CoA. I don't need where it is occurring. What I just need to trace it. Now, in most of this, you find that some of them break down are in twos. It does not matter. I give you this chart or this metabolic chart. Trace only one pattern. You don't need to make it two. If you look at fructose, fructose in the muscle can be converted to fructose 6-phosphate. From fructose 6-phosphate to fructose 1,6-bisphosphate, and fructose 1,6-bisphosphate, it goes to glyceraldehyde, and from glyceraldehyde, a complete glycolysis. You can also go through this way. From this way, fructose goes to fructose 1-phosphate. From fructose 1-phosphate to glyceraldehyde, glyceraldehyde can be phosphorylated to glyceride 3-phosphate, and then continue. So what happens is that I'll also talk about the muscle. I'm going to trace the part from the muscle pathway. Do not give me the two of them. I just need one of them. So from fructose to acetyl-CoA, let us take it off from there. So I'm going to look at it. We're going to always come at this, and then we're going to finish with this point because our acetyl-CoA is actually at this point. This is acetyl-CoA. So I'm going to go there, go through this, and stop at this point. That is how long that is going to be. Let's see what happens. So I'm going to start from fructose to fructose 6-phosphate. That's the first thing I have. So I'm going to say from fructose, you can use shortcut to fructose 6-phosphate. I can do this. From fructose 6-phosphate, I go back again and see what is happening there. Okay, no, forward, rather not back. Look at what is happening from fructose to fructose 6-phosphate. From fructose 6-phosphate to fructose 1,6-bisphosphate, I go back. From this to fructose 1,6-bis. You can use shortcut. At the point I'll be using shortcut. For now, let me continue writing like this. Then the next one, you see, I almost cover like this. It doesn't matter. You can just bend your arrow and continue. So I'm going to bend my arrow and continue at this point. From fructose 1,6-bisphosphate, what do I get next? From fructose 1,6-bisphosphate, it goes this way or that way. It doesn't matter. Just follow one arrow. Do not go back. That's what matters. If you want to go this way and continue this way, that's fine. But I'm going to go from fructose 1,6-bisphosphate to glycerol 3-phosphate. That's what I'm going to do. From fructose 1,6 to glycerol 3-phosphate. So that's the pathway I'm going to take. Now, I'm going to go back again. Fructose, I'm going to go to glyceraldehyde. Phosphate. And then from here, I'm going to continue. Look at what happens now. Okay, let's see. No, I went past that. Okay, I was supposed to go forward, sorry. Now, from here, it says continues to rest of glycolysis. What it means is that I'm done with that. I'm going to go to glycolysis. So at this point, I'm done. Here now, I'm going to go into glycolysis. So the next glycolysis chart, I have it here. Here, glycolysis. Remember, it is continuing from glycerol to what? From glycerol 3-phosphate. So I'm going to go through this. Where's my glycerol 3-phosphate? This is my glycerol 3-phosphate. This is my glycerol 3-phosphate. So I'm going to continue from there. From my glycerol 3-phosphate, it gives me 1,3-bisphosphoglycerate. I go back again. So from glass, it's going to give me 1,3-bisphosphoglycerate. So I'm going to use shortcut 1/3-bisphosphoglycerate. Remember, this is bisphospho. I'm going from 1,3-bisphosphoglycerate. What do I have next? I go back there. Let's trace it again. Go forward and see what I have. From 1,3-bisphosphoglycerate, look at what is happening here. Look at where I stop. 1,3-bisphosphoglycerate to 3-phosphoglycerate. I do it again. To 3-phosphoglycerate, I go back. So it's going to be 3-phosphoglycerate. 3-phosphoglycerate. From 3-phosphoglycerate, what will I get? I'll get 2-phosphoglycerate. But let's go back and trace it. I just want to make sure I put it very clear to you. From 3-phosphoglycerate to 2-phosphoglycerate. Go back. 2-phosphoglycerate. From 2-phosphoglycerate, I continue. It doesn't matter. Keep drawing the arrow until we get to what we want. From 2-phosphoglycerate, we're going to get phosphoenol pyruvate. From 2-phosphoglycerate to phosphoenol pyruvate, PEP. Remember, phosphoenol pyruvate is usually PEP. So I'm going to say phosphoenol pyruvate. I'm going to use shortcut. From phosphoenol pyruvate, of course, we're going to get to pyruvate. Let's go back and see. It doesn't matter. No, sorry. We're going to go rather forward. I put it in front. From phosphoenol pyruvate to pyruvate. That's what we got there. So let's go back. Phosphoenol pyruvate to my pyruvate. And then from pyruvate, what happens to pyruvate? All these things we've been talking about, all these ones are happening in what? In cytoplasm. Remember, from pyruvate get into the mitochondria and the rest of the reaction. However, we want to stop acetic CoA, so we're already there. So from acetic CoA, from pyruvate to acetic CoA, but let's just go look at it. Let's not just get ahead of ourselves. So it's going to be, we're in pyruvate. Pyruvate is not going to go and continue from pyruvate to what? Acetyl CoA. That's so it's from pyruvate to acetyl CoA. And acetyl CoA will join citric acid cycle. So we're there. So what I'm going to just have is what? Pyruvate to acetyl CoA. I go back. So I'm going to have from pyruvate to acetyl CoA. And this is how we've traced the path of fructose in metabolism to acetyl-CoA. I don't need the names of the enzymes. I do not need the reducing equivalent or the ATP released. What I just need is the names of the substrate. And this shows if you have the skill to be able to trace the conversion of this substrate to product, and from the product, which now becomes a substrate for the new enzyme, to be converted to another product. And that is how we do that. And having said that, we're going to come to an end of this lecture. Thank you for listening. Bye.